All right, in your notes, week 11 in computer concepts. So DevFest was last weekend. We had a great time. One thing I want to show you that we did was called the Google Cloud Spin. Check this out. So in the OAB, this is actually 11 Nexus 7s put in an arc, and then we did this like jump, and then every camera recorded it, and then it sent it out to the cloud, and then it stitched it all together. Looks pretty cool, right? There's some amazing shots that were taken on Saturday, but this is cool for me because these were all the folks that I worked with to help bring DevFest to Fresno City, and I'm just really proud of it, and it was a really fun day for me, okay? So that was the first thing. Second thing is my IT lab pro tip. By the way, have you heard this term pro tip? Bring it back. Have you heard pro tip? So first time I heard the term pro tip was from a Googler. I was traveling to London and they gave me a pro tip about how to recover from the flight. So pro tip is a professional tip. So my IT lab pro tip is that if you run into an item that doesn't work, skip it, right? And then either try to find somewhere else to do it, contact support, or what's the other thing some of you are doing? Go to Hangout, go to chat, see if other people have had the issue. Okay. By the way, there was one item in week 3 or in number 3 in Excel that I could never get to work. Some people did get it to work because I saw 100%. So, but my yeah, it was the one that you had to click on the piece of the pie of the chart. Yeah. Yeah, it just wouldn't work. So what's my pro tip on my IT lab? Skip it and, come in here. Come here and do the rest of them. Like if you're doing them at home, I think Lee and I talked about this, do them as many as you can at home, then come here and do the rest. Okay, my IT lab feedback, I think either week after next, we're gonna have the rep come in. But here's what I want you in your notes. I want you to all give at least 3 pieces of feedback about my IT lab, right? And it's not all bad. I hope you've learned some stuff, and if you feel like you have, I want you to say that. If you feel like you've been frustrated, I want you to say that. It really is important to me that we get your feedback. My IT lab is something we as a whole department have to decide on, and I haven't been totally happy this semester with some of the things that I've seen, but at the same time, I know that, what's the term I taught you all about my IT lab? It's very opinionated. It wants you to do it the way it wants you to do it, okay? So in your notes for next week, or for the online students for the week that they're in, this confused somebody one time when I said that. I want you to provide how many? At least 3. Okay, so we have week after next, and again it'll be the week of, for the online students, the lab test for Excel. So what I've provided to you, I was going to do a video because I went ahead and did it this week myself because I wanted to see how bad it was. It was actually not that bad. So here's what I'm going to provide to you is I'm going to provide you some print screens of what the output should look like in a hope that it makes it a little easier to do. So in this case, this item is actually a printed, so the print preview because you have to do some headings. And I will tell you this, and let's just be clear. The file that you're seeing scored 91%. The only reason I missed one was that, by the way, I noticed I could only submit it 3 times, so I'm going to leave it that way. Because you go through the whole thing, and if you submit it a couple times, you should be able to get most of it. And I'll show you the one item. Matter of fact, it was this one right here. Chart title. I forgot to put in the right chart title. That was one, and I think I had the style wrong. But other than that, if you want to look at this, that's the formatting. The other thing about this is I've also provided, anybody know what this view is called? No, this view of the Excel spreadsheet? Formulas. So what I did is I told Excel, show me the formulas for each of those areas. So when you're going through trying to do the work, you can refer to this to know what those formulas are. Okay? Do you think this might be helpful? My hope is that it will be. Yeah, so my hope is that it will be, okay? There was one other one I was going to show you real quick, right? So actually, so that is the formula view. And then I also provided you, in addition to the formula view on that one, I provided you what it will look like, okay? So you can go through here, there's 2 sheets that you'll do, Okay, when is that due? Not this Monday, the Monday after. Okay. All right, cool. So our topic today is networks. Really one of my most fun topics to talk about. And I'm going to show you, a little bit to my embarrassment, my own network. Okay? And you'll see why I say it's a little bit of an embarrassment. But just to say, what is a network? How do we define a network? Yeah, so in this case, we're assuming computers, but are there different kinds of networks? Sure, right? There's buses, there's all kinds of different networks, but yeah, we're talking about a computer network. Now, how important is having network connectivity to you? So I thought I might do a little chart for myself. And I did a little chart about my typical day and how much time I spend in different areas. And guess how much of my day I need network connectivity? The whole day. There's very little I can do without network connectivity. I get a little weird when I don't have it, right? And imagine how useful your computer devices and phones and all that. I mean, it's really not very effective or efficient when you don't have connectivity, right? Yeah, well, okay, that's a whole different topic. So here's what I want to do. I'm going to set the stage for my network that I'm going to show you. So here's how we talk about networks, okay? So my home network, and I will venture to say most of your networks, have the following characteristics. The first thing is we call it a LAN, a local area network. So networks are defined by their geographic space, okay? Networks are defined by their geographic space. Here is an image, right, of the way we can also think about this. So in this list, a personal area network would be that thing that connects devices that you carry on your own person, like Bluetooth devices. What's another thing you can think of that you have a personal area network that might have? Could be your phone. For me, it's my watch, right? So my watch is connected to my phone, although it can be connected to Wi-Fi. Local area networks, right? So we talk about these in terms of Wi-Fi. Bluetooth, could actually start running towards that, but as far as distance. Metropolitan are pretty wide. So like Fresno City also connects Reedley, also connects Clovis. So our campus network is actually called a MAN. It's bigger than a LAN because it covers what? More geographic space, okay? The mother of all networks, WAN, wide area networks. What would be the mother, the biggest network of all? The internet, right? By the way, come back here. Is there a difference between the internet and the web? Is there a difference between the internet and the web? How many of you, let's show them. How many of you say there is a difference? Show them. How many say they're the same? Yeah, they're different. So the internet is the network, the hardwire connection. The actual hardwire or software, what we call wireless connection, okay? And the web is what we do on that network. Now, by the way, it's not the only thing we do on this massive network, and we'll talk about some of them. All right, so the first thing we talked about in networks is what? How much space they cover, okay? So I have a local area network, what's also called a HAN these days. That's another term, a home area network, okay? Did many of you wake up one day and say, hey, I'm going to get a home network? Did anybody wake up one day and say, I'm going to build a network in my house? No, what caused almost everyone to get a home network? Internet, exactly, right? So you could share that internet connection out, okay? So again, we're just talking about mine. So my network is also what we refer to as a P2P, a peer-to-peer network architecture. So we're defining these things. So first, hopefully have in there the geographic space, and now we'll talk about peer-to-peer. Now let's get rid of that one. Okay, so there are two types of network architectures. One is a peer-to-peer network. And this is where no device has any more control than another device on the network. Does anybody know an example of a peer-to-peer network or in peer-to-peer? What is it? Say it again? Pirate Bay. Yeah, Pirate Bay is a website, but their architecture uses this, and underneath it is really what? We call it, there's another term. BitTorrent. So BitTorrent is a P2P network, okay? And the reason it's P2P is why? Because you can take one device off and it keeps running. By the way, the reason they took down Napster, because they were server-based. I think we talked about this a little bit, maybe not online, but in here. The reason Napster was taking it down is that they had one server that told where all the music was, and all they had to do was go over and shut it down. That's how they shut down Napster. What happened the day after Napster? Peer-to-peer. Okay? So we talked, this is network what? Architecture. These are the two most common. On this campus, which do you think we have? Do you think we have a peer-to-peer, or do you think we have a server-based? Absolutely, right? Why do we have a server base? So someone can control what happens around here, right? Otherwise, this would be a really scary place to be connected, okay? Just gonna say that. All right, so I have a LAN peer-to-peer architecture using a star topology. So here's different topologies. Topologies, have you heard this term, topology? We often talk about it in terms of geography, the topology, the landscape, but in networks we talk about it in the way that they're connected, right? So if we are connected in a line like this, boom, 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 right, one after the other, right? The difference over here is that we have a bus and then they're all connected out. What's the most common type of topology? Yeah, star and fully connected, actually, both of these. But the most common type for home is typically a star. And why is that? Okay, so let's say it this way. On this bus, if I was to cut accidentally the connection here, if they can see that, how many would die or how many would lose connectivity? Actually, yeah, 4. Everybody down line. On this one, if I cut it here, how many lose? All of them. On star, if I lose one of the branches, how many go down? 1. So in your notes, star is most common because it's the most reliable. Okay? Say it again. Yeah, we could. I mean, there are other topologies we could use. And you're right, you only typically have one. Even with that one, you could connect it differently. It's just the most reliable. It really goes back to reliability. Okay, so my network is secured for Wi-Fi. How many know what that means? What does secured mean? Yeah, so you have to have a passcode to get into my home network. Why is that important? Okay, so yes, if I have what's called an open network, which I say I leave it, and by the way, here's generally the response students do. It's like they're on their laptop or their phone, they're like, oh, open Wi-Fi, how cool is that? Right? Your response should be, uh-oh, open Wi-Fi. Why? Why should your response be more cautious than hopeful? Yeah, when it's unsecured, when you're connected to an unsecured network, everybody else connected to that unsecured network has access to you. So you should never connect to unsecured network unless you know them, and even then be a little cautious. Yeah. Yeah, so that's actually a different network. And by the way, the way we talk about this is through what's called SSID. You ever looked on your list and saw all the names of the networks around you? That's called SSID. So you can absolutely, on some routers, and we'll talk about routers and switches a little bit, but you can have 2 different SSIDs, one for your guest and one for you. But even for your guest, I would not leave it open because, and I'll come to yours next, Chris, why would I not leave it open? Well, and if anybody gets in and they do something illegal, who gets charged? Whoever's name is on the ISP bill. You got that? Chris. Now, Starbucks has actually started securing their Wi-Fi. When Starbucks early on, and if the online students didn't hear it, this is true for Starbucks. Even McDonald's now is offering us secured Wi-Fi. So you have to have a code to get in, right? Or they make it some other way because they understand the downsides of having a not secured Wi-Fi. Okay? But in the early days, it was true. Starbucks quickly realized they were reliable. Like, oh, maybe we shouldn't do that. Okay? All right. So you should secure your Wi-Fi in all cases. There isn't a case I could make these days for an unsecured Wi-Fi. Okay? So the other thing, the way we talk about, when we talk about networks in terms of hertz, 2.4 or 5 gigahertz. Anybody know what that means? Yeah. So it would make you think it is that which one would be faster. It makes you think 5 would be faster, but it's not. It's that there's so many on 2.4. And the more people connected on a band of Wi-Fi, the more people competing for a term you already know, called bandwidth. Okay? And we'll talk about bandwidth. So in this case, my network broadcast on both bands, and I tested the speed. There's not really that much difference. But the reason I would use this is because almost everybody else in my house is on 2.4. That means on this other one, sorry, on this one, I'm kind of alone. Sorry. See the problem with connectivity, right? People think they can contact. She will, exactly, right? Okay, sorry. All right, so the point about this is that these days, most of your Wi-Fi routers do support both. Now, typically, it depends on your house whether you use it. Now, here's the next one, and make sure you're getting this stuff in your notes, right? So the Wi-Fi standard is the standard that we're using to broadcast that signal, whether it's A, B, C, G, N, and actually there's a new one now. Anybody? AC. AC is not in draft anymore. It used to be. Now, what's the difference here? Anybody know what the difference? Hey, look, she didn't write back. That's nice. Okay. Yeah, it's usually range. So, speed and range. So, when you go from 802.11a, the older one back in 99, right, you can see how much distance, right, inside and outside, the max speed, right, all the way up to AC, which is really, this is a little old because these have been determined. So it's good to know the standard that you have because it's more speedy and it has wider range, but not a lot, right? I mean, look at that, from 100 to 225. So it doesn't have a huge range. And why would it be bigger outside than it is inside? Yeah, your walls are really, really critical. Like, I have an old house, and we have a lot of metal in our walls, and our Wi-Fi does not broadcast well. Yeah, it blocks it, right? So, again, let's go back to this. I'm telling you, this is the network, this is the standards I have. So this is Wi-Fi is wireless. Okay, you got that, right? So, wired is also an option that I have. Okay? So, but I'm about to show you my embarrassing network, okay? But I'm going to replace my Wi-Fi router soon. And I'll tell you why. But let me show it to you. And here's why it's a little embarrassing. Look at all those devices. This is kind of embarrassing to me, but oh well, right? So and by the way, take note because you're going to do this for next week. Okay? So and I'll show you, and by the way, anybody know what program I use to do this? Google Draw. It's part of the Google Cloud. So you can tell I use Comcast. Comcast is connected to our house via what kind of cable? Coax. You don't want a different kind. The only other upgrade you would want besides coax is fiber. And Comcast right now, as far as I know, does not offer that. There's only a couple of companies. Uverse, I think, offers fiber to your house. Now, why do you want fiber to your house? It's faster. I'm about to surprise you, I think, a little bit. So coax is great because it's shielded from interference. Okay? So my connection to, and by the way, anybody know what this device right here is called? My router. This is actually called a surfboard, and it does Wi-Fi and modem together. Now, I stopped about 2 years ago using it for both. Anybody guess why? Slowed it down. It couldn't handle both all my network traffic and all the stuff coming in. So I took that thing, I said, stop doing Wi-Fi. I bought another Wi-Fi router, okay? And this is working much better. But this is why I'm moving pretty soon to this device right here. Yeah. So Google has just released a new router, okay? And, you know, I drink the Kool-Aid. I get it, right? And I wasn't going to because I'm like, yeah, it's Google. It's version 1.0. It won't be that good. But every review I've heard of this says that Wi-Fi is excellent. Okay? So I'm not here to sell anything for Google. I'm just telling you this is one of the things I'm going to do because of what I'm about to show you next. So, but first, let's just look at my little network here, right? So here's what we have. Right, I have 2 MacBooks, I have a Pixel, I have an Android TV, I have 2 tablets, I have a Chromecast, I have a Chromebox, and I have a printer. Whew. Okay, there was a couple of devices I didn't list, but okay. Now, I actually am finding out that I'm not that unusual. Many of you have a lot of devices connected to your Wi-Fi, right? Right, if your TVs are connected, gaming systems. So here's what I want you to know. So do you see how this is like, by the way, I didn't show this, but what Comcast is connected to the what? Yeah, to the larger internet. And then I'm connected to Comcast through my modem and through my Wi-Fi. But this offers me a public IP. So in your notes, there's 2 kind of IPs. There's a public IP and there's a private IP. Okay? So the public IP, so Comcast, our Comcast, when they're looking at all the traffic coming in from my network to them, they only see really one IP address. And that's the public one. Now, how do you find the public one? I think we've done this, haven't we? What is my IP? So here on campus, same idea, right? So when you put these together, so all of us right now, all of us on this network, all the traffic that comes in through this campus and other campuses connected, that's the same IP. Okay, so that is the what? Public IP. Now, how do we get the private IPs? No, from our wireless routers, our routers. These routers do something called DHCP. DHCP. Basically what it means is it gives everyone connected an IP address if they have the secure code. If you can get in, that router will give you an IP address here. Now, by the way, who knows how to find that private IP address? Okay, so I'm going to do something on the network. And by the way, let's see if you can get this. What OS am I using here? What operating system am I using here? Mac OS. Okay? What is that? How am I doing that? Remote desktop. I'm actually through the internet connecting to a Windows computer through remote desktop. How? Now, again, a benefit of the network, right? Is that I can get in, like, you know, people call me, unfortunately, more than I'd like to say, hey, can you help me with this? I'm like, okay, remote desktop, I'll help you out. So if I want to find the private IP, okay. So if I want to find the private IP on Windows, I click Start. So put this in your notes because you're going to need to do this for next week. Start CMD, which is the command. So anybody remember us talking about command line? Remember? Yeah, so command line, there's other ways you could find it, but this is a really easy one. So on Windows, you just do command line, you type IP config. And then this online students won't see this as well, but you will. The IP address for this particular computer, and by the way, it's a Windows computer, right? It's 10.47.33.27. So each of you on this network have a different private IP. You got it? Start, CMD, and then it'll just run this, right? And then you can find your private IP so that you can put it in here. And by the way, notice, as I've said before, what am I doing to the IP addresses? I'm blocking out what? The last two spaces, and by the way, we call those octaves. So this IP addressing is a way to address all devices on a network and on the internet. Okay? So how can we get away with having these numbers be different than the ones out on the internet? Because of that router. That router is doing what we call network translation, right? It's actually taking, and when you have a request to go outbound, that router has to keep track of who you are so that when it comes back, it knows how to give it back to you. Because the internet doesn't know your private IP, which is the whole benefit of the Wi-Fi router or the router. Yeah, so let me say this, and go in your notes now until Sarah's question. Your router is also a firewall. A router is also a firewall. Yeah, Sarah.
So with the private IP,
right here?
yes. Does that apply to all of those devices, or does each individual device have its own?
Yeah, each individual device, as soon as it connects to the network, will get its own IP. It has to be unique, just like all of us on this campus have to have an individual IP that's different, so I can find you.
And then also, is it possible? I remember this from like way when I was going to school back in 2000. With the private IPs, are you able to change those to your own?
Typically, you don't change your private IPs because this device right here, your router, keeps track through the DHCP service. You don't really want to mess with those because it knows what numbers it's given out. Now, by the way, this number up here, this public IP from Comcast, will change periodically as well, unless I pay for what we call a static IP. You with me so far? So what are the two kinds of IPs? And how do you find the public? Online through what's my IP, and how do you find the private? For Windows. For Mac, let me show you, then Chris, ask me your question. That was it. On Mac, what you do is you do your spotlight, you type network utilities, and under network utilities, you go find your device, and it will tell you your IP. This happened to me yesterday. We couldn't figure out why my IP wasn't showing up. But you're at home, that's how you find your IP, okay? And there's other, by the way, on the Mac side, and Windows has this as well. It's just at the command line. There's a lot of other commands you can have, or that you have access to for your network. Ping, netstat, lookup, traceroute's great, okay? Okay, so for next week's hands-on part of the lecture, you have to map this out, which, by the way, these are actual devices. Did I take a picture of them? You think? No, what did I do? Images.google.com, right? And I said, okay, my Nexus 6, right? I found a good picture. I clicked on it. I did view. I did copy. And then I went over here and I pasted it in and I resized it. So I really do want you to tell me all the devices that you have connected to your network next week through this kind of thing. Well, I'd like to see that. So here's the other part of this. So notice who's my cell phone provider? T-Mobile. So these devices over here have both access, right? To both T-Mobile and to my home cloud. Which probably do I want to connect with? Why do I want to connect with my private cloud or my home cloud? It is, but that's actually not the primary reason because T-Mobile gives me that same feature. Yeah, so most cell phone plans say they're unlimited, but are they? No. Like T-Mobile tells me I'm unlimited, but the truth is, It's like you have this much high speed, and then when you use that up, we're going to kick you down to low speed, and we're going to call you unlimited. Okay? Come on. Right? What? I know, right? Okay. All right. So this is part of your work for next week for the lecture. Now, we're not done because I want to, first of all, did you get all that? So this is my kind of network. You don't have to describe it. I'm just telling you so you know some of these terms, right? And that's the way it's laid out, which, by the way, is this all the networks? And notice how I said some. Because what network did I not list here? The campus network. Big part of what I connect to the campus, but I didn't do it. I really only want your home, right? So by the way, anybody know what this stands for right here? No? Good. So I'm connected. Comcast connects to my cable modem through coax, a type of cable. My cable modem connects to my router versus twisted pair, another type of cable, okay? Now, I decided I'd do a little test. So I did, and this is our next topic, is bandwidth, right? Because it really was kind of amazing when I actually looked at all my devices to realize how many I had. And then I said, okay, we're all sharing the bandwidth of Comcast coming into my house. So let me do a little speed test between wired and wireless. What do you think the difference between a wired and a wireless connection is? How much faster? Okay, good that you knew that. Wired is faster and, by the way, more secured. But how much faster? Is it double? So here is my wired connection. And this is actually the MacBook Pro setting pretty close to the router, but logged in or connected into the wire. So 83 megabits per second. That's pretty fast. So here is the same device disconnected from the hard wire, connected to wireless. That's 167% decrease. And look at all those devices I have in my house. Why are we not all connected wired? Because it's a hassle. That's right. People don't. It's a hassle, right? Make sure you show the room. It's a hassle, right? But look at that. How many of you, if you really want to do something, what do you do? If for me, if I really am wanting to do something of heavy duty connectivity, I run over and get my wire and connect it in. That's what I do, right? Right. So, I mean, there are ways around this. So I'm not going to make you include this, but I do want you to know that, and I want you to test this out for yourselves.
I learned the hard way having two Netflix at the same time.
Yeah, oh, come on. If you're going to run two different Netflix connections and you're going to be shocked that your network is going to be bogged down, come on. How much bandwidth is your Netflix going to take? Let's just say you were on my network and you were Wi-Fi, 31 gig on Wi-Fi, how much is Netflix going to take? At least half. So, again, look at my network. How many people are on it? We're all sharing it. Why aren't and by the way, there's 4 people in the house. Why aren't more people complaining to me about the Wi-Fi? No, they all don't hit it all at the same time. Typically, somebody gets on, they read an article, they get on, they look at, they get off. They get on, they get off. They get on, all day. This is why we have some connectivity on this campus, but when we get too many people in a confined area, this is why Wi-Fi sucks. For not just us, but for your house. Yeah, question? Yeah. Yeah, we were talking about this earlier. I don't know if you were in. There's a 5 gigahertz and a 2.5. 2.4. So in that case, if I was getting network congestion, I would jump on the 5 gigahertz and let everybody else beat it out for the 2.5. And that's kind of what I do. Yeah. Yeah. Yep, right here.
Wouldn't it affect the Wi-Fi?
No, not really. Not really, because think about this. That's the amount of bandwidth I have if I'm hardwired. That's going to be my fastest connection. that Wi-Fi is, 167% decrease, right? These guys are not going to be, this one wired connection is not going to affect those Wi. But again, true, your router is going to manage that bandwidth. Which, by the way, the nice thing about that hub that I told you I was going to is I'm going to have a nice, where's it at? Here, this on hub that I'm going to, because I'm going to buy it, has a nice app that I can manage. So I'm going to pick and choose. No, no, yes. No, no, yes, right? What's the question? Yeah. Yeah, yeah. So here's the deal. Here's the deal. Remember this comment right here, or this in my description? This right here? Your router, based on the different standards that your clients, by the way, we talk about each device as a node. They're also clients. If you're running some older network connectivity, sometimes it'll bring down everyone. And that could be what's happening to you, which is why you want a dual band, so that you can get on this other band and leave everybody else to do the mosh pit on the other side, right? So also, again, the reason I want to go to a new router, even though nobody's complaining right now in my house, unless we have Netflix in more than one room, which we don't, but, you know. Okay, are you getting this? Okay, but are you getting the concepts? So we're talking about, what about bandwidth? What do you know now about bandwidth? Yeah, you're all sharing. The reason you all have, stay with me, the reason you all have a home network is to share the bandwidth in your house. That's the reason you got it, right? And so the more devices, the more likely you may get congestion, okay? Okay, so that's what I wanted to make sure you all understood in at least the concepts. Now, this IP4 that I was showing you, anybody remember this? So this is what an IP address looks like, right? There's actually 4 positions. Each position has 3 possible numbers, and they're called octaves, right? So this is, and by the way, we even know by the numbers, in this case, if it's a private or a public IP. We're not going to go there. If you were studying networking, that's what you would be doing. But here's the problem. We're running out of them. Why are we running out of IP addresses? Yeah, right? Anybody know about this thing called Internet of Things? Okay, in your notes, by the way, besides IP4, there is something called the Internet of Things. So now, all these different devices are connected, right, via networks. Your smart home, your connected car, right? Your maintenance, like, there's a thing I'm getting ready to get called Ring, that when somebody goes up to my door, it actually calls my cell phone and I see a picture of them. Awesome, right? Yeah. Creepy, really, but awesome. But that device has got to have an IP address, right? Well, yeah, right? Yeah. But still, right? I mean, there's all kinds of creepy things and cool things we could talk about. By the way, 60 Minutes ran a thing where they hacked into the new cars. That was all, right? They hacked into them, they hit the brakes, they speed it up because these connected cars don't have good security. Okay. So, well, McAfee's not going to help you. Okay. So here's the thing. We're going to go to an IP6 address. So here's an example of an IP6. No, you don't have to write it down. Here's what I want you to know, though. The IP4, because it's 4 positions, each has 3, is 32-bit. The IP6 is 128. But this is what I want you to keep in mind. Yeah, oh, absolutely, right? We can only get like 4 billion on IP4, and we're running out. And you can have a lot more billion on IP6. But here's the deal, keep in mind, it's still all zeros and ones. It's all it is zeros and ones being transmitted across the line. It's all binary. But ultimately, it's just a bigger address. Sarah? Okay, so we're not going to get there. This is not a networking class, but here's the answer, right? So the MAC address, there's actually an address for every piece of hardware, but we only use that to uniquely identify it for the network, okay? And then the subnet mask is actually a way that we sub the nets so we can configure them and isolate them. Okay, so IP6 is coming. We're already seeing it. By the way, did you see it over here when I did this? Do you see IP6 here? Right here, right? So most devices now do both. But we're going to have at some point a hard cutover where everybody's doing it. Yeah, but you have to know how to get into it. And most phones don't make it as easy as the computers to see your IP addresses. Okay? But again, my hub will allow me to do that. Okay. So the point about this is that we're running out of IPs and we got to do something, and we're doing it, but it's all still zeros and ones. And by the way, that whole translation of private to public will probably go away when we go here and make the network inherently faster. All right. So here's a concept that every network has to do, and it's called packet switching. So when and each device on a network is called a node. So each node, when it communicates, there's the message, and watch what happens to the message. What's happening to the message? It first got broken in, so the message got broken into pieces, and then those pieces did what? They each took a unique path. Why would it do that? Why would each packet take its own path through the network? That's right, because these nodes, if they're routers, tell it because the most efficient path changes second to second to second to second. And if they all went on the same path, that'd be called congestion. We'd never get anything done. So this is managed chaos. The fact that the internet works at all is amazing. But when you see this, it's like, holy mac, how do we make this thing work? Because this is what happens. You take it, you break it into packets, you send it throughout, and then and by the way, all the packets have to show up before this host can figure out what was said. And then once this host figures out what was said, it turns around and does the same thing going back. Yeah, some of them don't. Some of them don't go through part of because again, it's optimized. It's optimized based on, look, because this is only two people talking to each other, right? You talking to a server, you asking for Google, but how many people are asking for something in any moment of the internet? Millions, right? So there's going to be a lot going through those different nodes, and so it knows how effectively to send it. So this is called what? Packet switching. All right. I'm going to end with a story. Oh, no, I'm going to end two things. One is that if you're really studying this, Sarah, this is the network management. You do something called the OSI, the Open Systems Architecture Information. And really, here's a thing to think about. Because this used to be my job, was building networks. I'm going to tell you the story in a minute to finish. But can you imagine if we didn't have standards, how we could make all of these computers all over the world work? Right? Think about that for a minute. Like it's called, and put this in your notes, protocol. So protocol, and if you've ever heard the term, you may have heard it related to how people talk or how they interact. And the most common one is like when you meet the Queen. Do you know there's a protocol when you meet the Queen of England? Anybody know what it is? You bow, and you don't look at her in the eyes. Don't know why. Don't ask me, okay? And by the way, did Michelle Obama do a big, bad protocol faux pas with the Queen? Yeah, she touched her, right? So, I mean, but the point is that protocols are there to standardize and to help us work in the world, but for computers, we have to have them. Without a standardized protocol from everything from the physical layer all the way up to the application layer, we couldn't do anything at the massive scale that we do. Understanding networks is so important. So this is called the OSI model, and if you study network, you will learn it. I'm going to end with a true story today. So one of me versus IBM. So when I was in industry, I was hired on as a network administrator. kind of a lowly network administrator. And then through the years, I got promoted up to the network systems engineer. And there was this thing called Y2K. I don't know if you've heard of it. Yeah, it was a long time ago, 16 years, well, coming up on 16 years ago. But Y2K was an opportunity for many companies to upgrade their networks. So the company I was working for, Duncan Enterprises, anybody heard of them here in town? Pretty big size company. They came to me and they said, Rio, we're going to give you about $2 million and we're going to have you upgrade our networks. I was like, what? You know? And they're like, we want you to go do the research and find the best thing for us to use. So I did. Now, at the time, IBM was running and promoting the Ring network, Token Ring. They thought it was the cat's meow. I didn't. My research showed this was not going to work long term. It was not reliable. It was not scalable. But IBM said, no, it is the way it's going to do. And I said, no, I think Star is going to make it, and I think this thing, and I want this in your notes, called TCPIP. TCPIP is going to be the thing, along with Star. So, I went back to my boss, right? To my boss, I said, listen, I think this is where we should go. We should do an Ethernet TCP/IP Star network on with this $2 million. So, my boss told IBM. What do you think IBM said? They actually called me stupid to my boss. What do you think my boss did? You think? He did trust me. He knew I did my research. He said, okay, Rio, we think you're right. Now, how hard is it to stand up to somebody like IBM? This is exactly how I felt. But I knew I was right. By the way, how long do you think, and by the way, today, the standard protocol, TCP/IP, Star, right, Ethernet is the standard across the world. Now, oh, I did. So this was the joy of my life. IBM, after they selected my decision, would come in because we had mainframes that they maintained. I had the best time. When they'd come in, I'd just chuckle. I just had this little, you know, because I got a nice bonus, really, because it wasn't long. It wasn't long before they knew the decision that I made was right. And what I did is I did really good research. I'm a really good researcher. I know how to research things. So I'm telling you, these skills that you're learning are good. It's not that I'm the best, it's that I knew what to do. And it's hard to go up against the big guys and tell them what to do. Or at least tell them what I thought they should do, right? So Y2K was good for me. All right, so next week, here's what you're going to have to do in addition to the notes, which I know are long this week, but I think this is a really important topic, okay? So I want you, in addition to the notes, do the network that we talked about, right? And let me just show you real quick. Of course, I don't know. And by the way, next week we're going to talk about the web. Because the web is what? The internet is the internet is the network. The web is the software, what we do on that network. We do other things as well. So let me just show you real quick so you have it, how to do this. I'm going to go to Drive. Good, we have the screen. I'm going to do New. I'm going to do here. It's going to be called a drawing. And under drawing, this is just good to know how to do. Right, see there's these shapes. Right here is where I use the cloud. Let me show you where I got the cloud. See that? And then I just drew the cloud. Okay, it's really easy. And then when you want to do lines, you come over here and you're like, okay, let me draw a line right here. Here's a line from here to here. And then when you have it, you can tell it, I'm going to make it bigger right here. Line color, line height, if I want to make it like that. Okay? It's really easy to do. So then you lay upon that. So here on your network, I want to see who your provider is, what kind of connection. These are wired connections, coax, twisted pair. I would like to know what your IP, public IP is. I'd like to see the devices. I'd like to know what your private IP is. And again, right, you can star out any two of the last items. And then I want to know who your mobile network is, if you have them, and which devices bridge, or not bridge, because bridge is actually a network device, or a network term, but have both cellular and your home network. Okay? And then what you'll do is provide me a link in the classwork for next week. Okay? Did you get something from today? Feel like you walked away understanding networks a little better? Yeah, the on-hub right here. You can just search for it. Search for on-hub. What was right here. I can't show the video, but I will after we drop because you know how I feel. So let's show them. Say goodbye to everybody, and we will see you next week.